Today we're going to be discussing the subset sum problem and how we can use the particle swarm optimization to solve it. The subset sum problem is a classical problem in computer science and is often used to illustrate computational complexity in algorithmic design. The subset sum problem involves a set of integers and a target sum, and the goal is to determine if there's a subset of these integers that add up to the target sum. The particle swarm optimization is a computational method that is used to optimize a problem iteratively. It tries to improve a candidate solution regarding a given measure of quality, and it does this by having a population of candidate solutions, which are referred to as particles. The movements of the particles are guided by their own best known positions in the search space, as well as the entire swarm's best known position. And so when we look at the code, we can see that we initialize a swarm of 30. Each particle has an inertia of 0.5, which influences the direction that they move. They also have a cognitive and social component, which add diversity into the population, and there's max iterations of 1,000. The constructor initializes a list of numbers, which is the subset, and the target sum. And so when we run the code, we initialize the swarm of particles and the global best particle, and then we iterate until we find a perfect solution or we hit the maximum number of solutions. This is where we initialize the swarm. This is where how we calculate the fitness of a particle. It basically initializes a sum of 0, and for each element in the particle's position, if the number is included in the subset, then we add the number at that index to the sum. And then we return the absolute difference between the target sum and the sum. Then this is how we update the particle. Nothing super interesting here. This is our sigmoid function, which is just a basic particle, which is used to update the particle's position. This is how we get the subset from a particle position. And so for this program in particular, I have it running 50. I have the algorithm running 50 times, so that we can compare the results over a bunch of different runs. And so for this, we're going to enter, say, 15 numbers into our subset. I'm just gonna put a bunch of random stuff. Give a sec. Cue the Jeopardy music. Oh, that's a big number. Maybe I shouldn't put that. Oh, there's another big number. Maybe I'm just gonna put a lot of big numbers now, and we'll see what this does. And I'm gonna put 35, and we're gonna put 500. Oh, we actually hit it. That's crazy. But it did take a lot of iterations. And so it does look like there is some combination of these numbers that adds up to 500, and that's indicated by our best fitness being 0, which is the lower the fitness, the better. And the subset sum is 500, so we did it, and it actually turned out to be quite good. So thank you very much.